This is a video of the solution to question 8 on page 469 in book 4, and it's a question on modular functions. So I've got two functions in this case, f of x and g of x, and we want to sketch them on the same graph, and we want to solve f of x is less than or equal to g of x. So let's take a moment to look at the two functions. The simpler of the two is g of x. It's just a linear function. It's written in the form mx plus c. The plus c isn't really written in, but we can put it in, plus 0. So it goes through the y-axis at 0 and it has a slope of a half. The f of x has a modular part. The minus 4 isn't inside of the absolute value lines, so we just have to watch out for that. Probably the easiest way to sketch f of x is actually to stick a few values in for x and see what they come out as. And I'm going to use the values minus 4 up as far as positive 4, and I'm kind of being guided in that direction by this 4 at the end. That's kind of what's giving me the inclination to use those values minus 4 up as far as 4. And I might find that I need to actually extend my values of x out beyond those values. So I'll leave a little bit of extra space on my table just in case I need to do that. So I'm setting up a little table there for my two functions, one for f of x and one for g of x. I've listed out the x values that I'm going to use. I've left myself a little bit of space either end just in case I want to extend beyond those. And now I'll put those values into my functions and get out my y values for each function. So I've got a set of values now for f of x and a set of values for g of x. So I have my xy plane set up now, and I'll plot the points and join them together to make the two functions. So I've filled in my points and I've joined up to make my functions. You can see there with my g of x, which is in orange, that I've extended beyond the points that I'm given. And I could actually do the same with my f of x if I wanted to, because although it's not kind of a straightforward line, it is linear on both sides of the y-axis. So I don't strictly have to go back and fill in more x values into f of x. I could if I liked. I might just stick in 5 and 6 and see what happens with those. So I'm putting in those two extra values up here, and they're giving me out y values, and then I'll just extend my function accordingly. I haven't quite done enough still because I'm looking for where f of x is below g of x, so I'd really need to see where both of those intersect. So I'm going to extend both of those functions slightly more to make sure that they do actually intersect. So like I said, if we're looking for where f of x is below g of x, I'm going to be looking between those two intersection points. So I need to identify them as accurately as I can. And just bear in mind that no two graphs are going to be exactly the same. So if you've got a slightly different value to me, don't worry about it. Just try and be as accurate as you can for your own diagram. And again, the more accurately you've drawn your graph, the more accurate your results will come out at the end as well. So, okay, so where is f of x below g of x? Well, g of x is the orange line, and I can see that f of x, the green function, is below it between those 2 points. I need to get the x values, and I can see that the x values of those points of intersection are about minus 2.6 or minus 2.7 and 8 over here on the right hand side. Okay, so I want to solve an inequality, so I want to use inequality symbols in my answer. So you can see that the green function is below the orange function to the right of the minus 2.7 value and to the left of the 8 value. So I should write my answer as x is greater than or equal to minus 2.7. and x is less than or equal to 8. And since it's all in one piece, this portion of the function which is below g of x, then I can write it as one statement if I like, which is that x is between minus 2.7 and 8.